started, and we will record for everyone who's at home as well. Lesson 16. Oh, I'm using green. This is from Oasis, using green because he always uses green for Shrek. Yes. All right. Lesson 16, rounding whole numbers and estimating. First off, what does rounding mean? Rounding is when we are working with a whole number. We are finding another whole number using usually ending in 0. That is close to the number we are rounding. So, for example, the number line can help us with this. So, usually when you're rounding in your head, you're not going to be using the number line. You're just going to be thinking about it. But for our purpose, let's look at a number line. So I have a 3, a 4, and a 5. I'm going to put half marks in between. So this right here would be 3.5, and then 4.5 in between the 4 and the 5. So if I had a mark right here, let's say this is 3.3. Brady, am I going to round that up to 4, or am I going to round that down to 3? Yep, I would round it down to 3. Grace, if I have 3.7, am I going to round that up or round it down? Up, yep. Talon, if I have 3.5, is that going to be rounded up to 4 or down to 3? Up, yep. So whenever you do have 3.5 or anything that is 0.5 or a half, you're going to round up in every scenario. Okay, so that is what we're going to do for rounding. Yeah, Grace?
I was told that if it was 5, you rounded down.
No, with 5 you always round up. Yep. Yep. 5 you always round up. So if it's 3.50000, you're rounding up. 3.49, you're going to round down. Yep. Okay, and that's pretty universal, so every math teacher should know that anyway. Okay, round 6,890 or 6,789 to the nearest thousandth place. First off, where's our thousandth place? Yeah, Brady, which number is in our thousandth? The 6. The 6 is in our thousandth place. Good. So Brady, what am I going to round this to?
You are going to round it to 7,000.
Yep, going to round it to 7,000. Good. I'm going to give another example right here. Let's do Grace, 6,489. Am I going to round that up to 7,000 or round it down to, yep, round it down to 6,000. And then Talon, I have 6,500. And my thing is lagging. Yep, round it up to 7,000. Good. Okay. Oh, and that was what they were doing in example 2. So example 2, they said their example was 550, round it to the nearest 100. So if I round that to the nearest 100, Grace, am I going to round that up to 600 or round it down to 500? Yep, I'll round it up to 600. Yep, and that's what it says on example 2 at the bottom of page 77. All right, so that's example 1 and example 2. Those are pretty quick ones. Let's try example 3. Example 3. This is all review for you 3 so far, right? You guys have worked with rounding, right? Shake your head yes or no. Yeah, yeah, okay.
I thought product was when you get it after you're done subtracting.
Yeah, product is multiplication. Product is multiplication, and I'll write that up on the board real quick. We're not working with that, but I do want to write that up here.
Yeah, because I always get confused.
Product equals multiply. Sum equals addition. And we've gone over this already, but I want to just make sure we got it. Quotient is division. And then difference is subtraction.
Okay, that's new.
This should not be new to you. This is definitely review. Product is multiplication, sum is addition, quotient is division, difference is subtraction. Yep, so that is definitely something that should be known already. Yeah, if that helps you remember, there you go. Okay, example 3, estimate the sum of 467 and, that's my and sign, and 312. So estimate the sum of the two. So we're going to round them to the nearest, both to the nearest 100. So Grace, what is going to be my answer here?
Well, 400 goes to 500.
Yep.
And then 300 goes to 312 goes to 300.
Yep.
And it'd be 1,200.
So if I were, it wants the sum, what would sum be? Is that addition, subtraction? Addition, subtraction, multiplication, or division for sum?
Addition.
Addition, yep.
And 800.
Yep, 800. Good. So sum is addition, so on and so forth. That's another way of hearing that. Okay, let's try example 4 to finish us off. We have a word problem. So according to this graph, we're on page 78 towards the bottom. So according to this graph, about how many more people lived in Ashton in 2000 than in 1980? So about how many people lived in Ashton in 2000 than in 1980? Yeah, Brady, help me read that graph.
Wait, I don't answer.
Okay, so for in 2000, about how many people lived there? Yep, 7,000 people lived there in 2000, in the year 2000. Were any of you born yet? No, you guys weren't born yet.
I was born 2009.
2009, oh wow. Oh, that's true, I was born in 95, so I would have been 5. You guys were not conceived
I
yet.
would have been -9.
Negative. Some of your guys' parents probably weren't even together yet, or maybe they were. Okay, 2000, in the year 2000, there were about 7,000 people. So in 1980, Grace, how many people were there in 1980? About 4 what? Is it just regular 4? So look at the y-axis. It says population in what? In 1980, yeah. I'll show you. Yeah, you're right. It's 4, but it's in 1,000. It would be 4,000. Oh, okay. So how are we going to find, it's asking for how many people, how many more people lived there in 2000 than in 1980? How would I figure that out, Talon? Yeah. Yep. So 7,000 minus 4,000. I'm taking my larger number, which was in 2000, minus 4,000. So that means 3,000 more people now live in Ashton in 2000. And if I were to make a prediction, this isn't what you guys are doing, but if it went up by about 3,000, that means in 2020, which is this year, what would you guys expect the population to be now? If it were to keep this trend going, what do you think, Johnny? What would you think the population trend would be? So in 1980, it was 4,000. 20 years later, it went up to 7,000. What would you predict it would be in 2020? Yeah, just 10,000. We're not for sure, but based off of this graph, we could guess that it would be about 10,000 in 20 years. All right, that's all I have for you guys. That part you're not going to be doing. That's just something that you will be doing when you're working with, let's say, stats. Some of you will be taking statistics one day in a higher level math. Reading graphs is important when you're working with that kind of stuff. So that's why we work with graphs.